And we are back. Hello everyone, welcome back to 5 Minute Code channel where I will be explaining the solution of every problem of Lead Code and Geeks for Geeks within less than 5 minutes. Okay, so today's problem of the day is it a tree? Okay, so which is a medium level problem, and I also think it's a medium, but it's a bit on easy side if we can break down this problem in small parts. Okay, so all right, let's find out what we will be given into this problem and what we have to do. Okay, so we will be given two integers n and m, which means n will be the number of nodes and m will be the number of edges. Okay, so if you know what are nodes and edges, it's great. So basically, nodes are the children are the nodes with which have values and they are the references to the other nodes. And edges means that the nodes like edges connect the node. Okay, all right. So what we have to do, we will be given to n and m nodes and edges, and we will be given an array list of array list that is edges. Okay, so this is basically means what 0, 1, 1, 2, 1, 3. It means there is an edge from 0 to 1. There is an edge from 1 to 2. There is an edge from 1 to 3. Okay, 1 to 3 as well. So it's basically undirected. You will see undirected means there can be edge from 0 to 1 or there can be an edge from 1 to 0 as well. Okay, so basically you have to tell whether this graph which is given, is it a tree or not. Okay, so you might be thinking, oh, it's a tough problem, how are we going to solve this? But I have written something for you which I already say as notes. So if let's jump onto the notes section for it, and after that this problem will become very easy to you. Okay, all right.
Okay, is it a tree? So what are the conditions? As we know, as we all know, that all the graphs, all the trees are graph, but all the graphs are not tree. Okay, so what does this mean? So look, there's a graph. So when that graph will be a tree. So look, first thing is there should not be a cycle. Cycle basically means if I take this as a graph. So if there is an let's say this like something like this. 0 1 1 2 3 4. So it's not a graph, it's not a tree because there are no cycles into a tree. Okay, so first thing is correct, clear. There should not be self loop basically means cycle only. So suppose there's an edge from 0 to 1 and after that there's an edge again from 1 to 0. So these are self loops. Okay, which is a type of cycle only. Okay, and second thing is graph should not be unconnected. What does this mean? Suppose there's a graph in which there are two parts. One is this 1 to 2, and then there is 3 to 4. Both are independent. There are no connection between these two. There is no connection between 1 2, and there is no connection between 3 4. Okay, so it's an unconnected graph, so it cannot be a tree. Okay, so these are the few things which there should be into a graph, then my graph will become a tree. Okay, all right, so now let's talk about the technical terms. These are some theoretical things, but how are we going to solve it into the program? So first thing I'm going to find out is number of edges should be equal to number of nodes minus 1. This is first property of the tree. So we will be given edges, we will be given nodes. I can easily check this. So suppose here you will see number of edges is what 1 2 3 4 5, and number of nodes are what 0 1 2 3 4 5 6. So 5 equal to 6 minus 1. So this is a true case. This is a universal truth for tree. So now look, if this case is correct, now we don't need to check for cycles, we don't need to check for the self loops. All these are covered here. Only one thing which I need to cover is for unconnected. So 1 2 3 4. Okay, so this property I need to cover, and all others are already covered. How? Look, if number of edges equal to number of nodes minus 1, in that case, if there suppose there's a cycle, so now number of edges is equal to 1, number of nodes, number of edges equal to number of nodes. So yeah, we failed hit here and it will return false. Okay, similarly suppose now there is unconnected graph 1 2, then only in other part of the graph there can be a cycle. Okay, I think you guys are getting in this such like this. So here I can only check, oh, it's unconnected. So yeah, I will return. All right. So yeah, I think the problem has been broken down into very small part and it's become crystal clear to you. So how are we going to solve this? Look, we will be making an adjacent list. I think everyone knows what adjacent list is. So basically there will be some edges. So from 0, look, there will be a list of list. Okay, so 0 1 2 in this space type, and from 0 I will collect all the edges starting from 0. So like here there are two edges 1 and 2 from 0. Okay, and if I check from 1, there are two edges again. There are one edge from 2 0 only. Okay, because it's undirected. From 2 there are basically three edges 0 3 and 4. Okay, I think you guys are getting what I'm explaining. So in this way I will do, and after that I will simply start from 0. I will simply start from the 0. I will cover all the nodes from 0. So like 1 is covered, 2 is covered, and now from 2 again I will traverse all the nodes. So I will go to 0. Oh, it's already visited. I will go to 3. It's visited. I will go to 4. It's visited. Then after that 5. Yeah. So I will check. Oh, all the nodes are visited. So I will return true. But suppose there are two unconnected. So something like this 0 1 and 1 2. Okay, 1 to sorry 0 to 1 and 2 to 3, something like this. There's a graph. Okay, so I will start from 0, I will go to 1, but from 1 I can't go anywhere. Okay, so it's an unconnected graph and I will return false. All right, so very much explanation is done. I think it's become very clear to you. So now let's jump onto the code section for it. But before writing the code, if you have loved the solution, please don't forget to subscribe the channel, like the video, and comment your feedbacks. Okay, all right, let's write the code for it.
Okay, all right, let's go. So first of all, what I told, if my edges are what? If my edges, that is m, not equal to n minus 1, and are what? Nodes n minus 1, so I will return false. Okay, first thing. After that, look, first of all, I will be making one visited array, let's say boolean viz, which will be counting the number of nodes already visited. So number of nodes is n. Okay, and after that, as I told, I will be making one adjacency list. Adjacency list is what? Array of array list. Okay, so it will be something like this: array list of integer. Okay, and it's an array. Okay, so basically array of array lists. So new array list, something like this with the size of n. Okay, it means what? It means at each index. So basically we can make array, we can make an array of integer, we can make an array of boolean, we can make an array of double value. So similarly there is an array of array list type. Okay, so this is what this means. Now at all the indexes of this array, I will be making a new array list. Okay, so how I'm going to do this: for int I equal to 0, I is less than n, I plus plus. So basically I'm initializing, because otherwise I can't store. So it will be something like, let's name it something, let's name it adjacency adj. Okay, so it's basically adj of I equal to new array list. Okay, so at each index of this adj there is an array list. Now I will be simply storing. So how I'm going to do: for array list of integer type edge, which will be coming out from this edges array list. Okay, something like, so basically look, if this portion you got, it's basically used in all graph questions. Okay, now which what? Look, adj of h0 index, I will add what? Adj h1 means what? What does this mean? H0, sorry, we will be writing something like h dot get 0, h dot get 1, something like this. Okay, so what does this mean? This means key there is an edge from 0 to 1. Okay, and similarly, since this is undirected, so I will be doing h1 to h0 as well, something like this. So basically this is a way to make adjacency list, and after that I will start from 0. So current my node is 0, I will make a queue of integer type, new linked list, and I will make first of all my 0 node as true, because I've already visited it and I'm starting from that. And let's count my visited nodes total equal to 1. Okay, so if at last all my nodes are visited, it means we have a tree. Okay, because I already told. So I will add this q dot add 0, because I will be starting from 0, and I will do something like while not q dot is empty, take out one node, current equal to q dot poll. Okay, and after that, look, so what I told, I'm starting from 0. So look, from 0 I got 1. Okay, now from 1 I will start all other nodes. Okay, so I will start all other nodes, means that's why I make this adjacency list. So I will do something like, for int, let's say never will come as any I, and I will be taking out from adj of what? Current. It means like it will be returning adj current will return me a new array list. Okay, an array list, and in that array list all the neighbors of this current will be there, and I will traverse them. This simply means that only. Okay, so if not visited, and yeah, if it is not visited, then only I will visit, because if it is visited I will don't repeat it again. So viz of any I equal to true, and I will add it to the queue as well, q dot add any I, and after that, look, I will add my total to plus plus, because I visited one more node. Okay, all right, and here after coming out of this while loop, I will simply check if the visited nodes is equal to my n. So if it is true, if the total nodes, sorry, if the total nodes is equal to n, means total visited nodes is equal to n, it's like we have got our answer, that is true. And if it is not, we will return false. All right, let's submit it. So if you will do a dry run of it, I always say please sit with a pen and a paper and please dry run this code once, so that it will become more clear to you. Okay, all right, so I've got my geek quit and I solved this into my first attempt as well. Please subscribe the channel, please like the video, share your feedbacks into the comment section, and I will see you again tomorrow, and keep on coding.